All right, happy Tuesday, y'all. Today we're going to continue our study of similar triangles and talk about proportionality theorems. So, similar triangles, which we talked about previously, all follow a specific proportion. Well, today we're going to talk about two special cases in which triangles follow proportions based on other things. This first theorem is called the side splitter theorem. And it comes into play whenever you have a line that intersects two sides of a triangle and is parallel to the third. So look at this figure right here. I have triangle ABC and it is intersected by the line segment DE. Now these arrows say, hey, segment DE is parallel to the third side of the triangle. What happens here is the sides that are intersected by this line segment are divided proportionally. Okay? So, here is the proportion. This distance, BD, over this distance, DA, whatever that proportion is, this distance, BE, and EC, these distances will follow the same proportion. So, no matter what, those values will always have the same ratio. So let's set up a couple of these. For each of these, we're just going to solve for x. For the first one, I've got this line segment that is parallel to this third side. On the left side, I have 15 and then 6. The proportion 15 to 6 will be the same proportion as whatever this number is to 4. So set up that proportion. 15 over 6 equals x over 4. And then you just cross multiply. 6 times x is 6x. 15 times 4 is 60. Now, I need to solve for x, so I'm going to divide both sides by 6. And for this first example, that leaves me with x equals 10. And if you double check, 15 over 6 is the same ratio as 10 over 4. Let's look at another one. Now look at this next one. I'm not solving necessarily for a side length here. I'm finding the value of x that works. So let me focus my camera a little bit. This line segment intersects with my triangle. The horizontal side on the bottom is divided at a 20 to 8 ratio. The side up here, the kind of slanted vertical side, or not vertical, diagonal side, is divided at a 2x to 5 ratio. So I'm going to say 20 over 8 equals 2x over 5. Notice that I'm always doing kind of the number closer to like this angle first, right? I'm working from 20 over 8 and 2x over 5. You want to put them in that order every time, otherwise it's not going to work out. So like I did 15 over 6 and x over 4. Okay, so 8 times 2x is 16x. 20 times 5 is 100. And I'm going to divide both sides by 16. I should have grabbed a calculator before I started all this. There it is. 100 divided by 16 is 6.25. Now we're just solving for x here, but the actual side length is 13. And you can double check. To double check these, try 20 over 8, plug in to find this side length and try that over 5, you'll get the same value. So 20 over 8 and 2 times 6.25 over 5 both give you 2.5. So it's a 2 to 5 or 2 0.5 ratio between those two numbers. Let's try this next one as well. So starting from this, I've got 7 over 21 and x plus 1 over 15. So this is tricky. When you cross multiply 20 to x plus 1, there's kind of an understood set of parentheses around here, meaning you've got to distribute 21 to x and 21 to 21. Okay? So this 21 times x plus 1 gives you 21x plus 21 equals 7 times 15 is 105. So if you don't distribute that, you're going to be lost. Okay? Subtract 21 from both sides and divide by 21. So 21x equals 84. Divide by 21. And you end up with x just equals 4. Okay. Try the other three that you see here on the screen. Take a couple minutes, pause the video, and try the next three. Okay, so let's get started on these next three. I'm going to start with 20 over 11 equals 30 over x minus 3. Now, you may notice that for this one, I've put the x on the denominator, whereas my first three examples, x was in the numerator. It does not matter. It does not matter because when you cross multiply, the fractions immediately go away. So, 20 times x minus 3 is 20x minus 60 equals 11 times 30 is, of course, 330. Then I'm going to add 60 to both sides, which gives me 20x equals 390, and then divide by 20 to get x equals 390 divided by 20 is 19.5. Okay, moving on down to the next to last. I've got 8 over x minus 5 equals 7 over 19. Cross multiply. X minus 5 times 7 will give me 7x minus 35 equals 8 times 19, which is 152. We're going to add 35 to both sides, which will give me 7x equals 152 plus 35 is 187. And then divide by 7, which will give me x equals 26.71428.571. Let's just round that to about 26.7. So I'm going to change that to a squiggly equal sign to say approximately 26.7. Okay, last one. I've got 15 over 2x plus 1 equals 41 over 12. Okay, cross multiply. 41 times 2x plus 1. 41 times 2 is 82. Yes. X plus 41 equals 15 times 12 is 180. Well, we're going to get a weird decimal here, I bet. Subtract 41 from both sides to get 82x equals 139. And then divide by 82. And that's where the weird decimal comes in. We get a beautiful 1.69512191. We get that. So I'm going to round that to 1.7. You know, I mean, if it doesn't say what to round to, just round it to the nearest tenth. Okay, so that was the side splitter theorem. If you need to see any of this again, I'm going to leave it on the screen for just a second. I'm also going to drop this into your Google Classroom in case you need to copy any notes you may have missed. We have one more theorem to talk about, though. It is another proportionality theorem called the angle bisector theorem. Now, we have already talked about angle bisectors themselves, but angle bisectors in triangles also end up with the proportionality theorem. So, if a line bisects an angle of the triangle, the third side, or the opposite side of that angle, side is divided into two segments that are proportional to the third side of the triangle. I think I typed that out wrong. The opposite side is divided into two segments that are proportional to the third side of... Okay, yeah, I didn't make a mistake there. So this long side across the bottom is divided into AD and CD. The lengths, you know, how much each get is proportional to this side of the triangle. So here's the proportion. BA divided by AD will always equal, if we have an angle bisector, BC over CD. So let's set up those proportions. For all of these, we've got an angle bisector. For the first one, I've got an angle bisector. I'm going to do 8 over x. So 8 over x equals 12 over 9. So make sure you're following that pattern there. Start at where the angle bisector is, go down until where the angle bisector kind of cuts the third side of that triangle. Okay? Cross multiply. We've got 12 times x is 12x. 8 times 9 is 72. If I divide by 12, I believe I'm going to get 6. Is that right? Yes. X equals 6. Okay? You can double check. 8 over 6 is the same thing as 12 over 9. Let's look at our next example. I'm going to say 10 over 4 equals 3x over 11. Now note, if we're going to check our work here, we have to plug it back in. Okay? So, 4 times 3x is 12x. 10 times 11 is 110. Divide both sides by 12. X equals 9.1666666666666. Here, if you ever get like a repeating decimal, I would say instead of rounding it to 9.2, you can get the exact answer if you just say 9.16, little line over just the 6. We're not rounding here, we're just saying, hey, I'm not going to write all the 6's to Kingdom Coming Back. It's just 9.16 repeating. Okay, try those next 3. Be careful, or excuse me, next 4. Be careful because the next 3 require you to distribute. So take a minute, try these 3. I'm going to leave these up here, pause the video. Okay. So, this first one that I had you try on your own, Let's do 8 over x minus 2 equals 5 over 3. And 5 times x minus 2 is 5x minus 10 equals 8 times 3 is 24. And then I'm going to need to add 10 to both sides, which gives me 5x equals 34. And then divide both sides by 5. And I think I get x equals 6 point, is it 6.8? Yeah, 6.8. I got to be careful about doing my mental math and getting it wrong on the video. That would make me very, very embarrassed. Okay, so the answer to that first one was 6.8. Next one, 12 over 5 and 17 over x plus 3. It really doesn't matter if you say 17 over x plus 3 equals 12 over 5 or vice versa, so long as you just have 17 over x plus 3 and you have 12 over 5. So 12 over 5 equals 17 over x plus 3. Cross multiply. 12 times x plus 3 is 12x plus 36 equals 5 times 17. 5 times 17 is that 85? Yeah. And we're going to subtract 36, and that gives us 12x equals 49. And then if I divide by 12, if I divide that by 12, that leaves me with x equals 4.083 repeating, with just the 3 being the thing that repeats. So yeah, I can get the exact answer. 4.0833333333. Just put the bar over the 3, okay? Next one, 2x plus 3 over 14 equals 23 over 14. Now this one is actually surprisingly easy. Look at that bottom side there. Or excuse me, look at the side that was intersected there. It was divided proportionally, but they're the same thing. So if 2x plus 3 over 14 equals 23 over 14, if you ever have something like this where you have a fraction equal to a fraction and both the numerators or both the denominators are the same, I mean, look. Yeah, 2x plus 3 has to equal 23. But we're going to solve this the same way we have been, but we could do this a lot quicker just by dropping the 14s. So 14 times 2x plus 3 is 28x plus 42 equals 14 times 23. Don't know that one on my head. 322. Subtract 42 from both sides to get 28x equals 280. And then divide by 28, and 280 divided by 28 is just x equals 10. And we would have gotten that if we had just said 2x plus 3 equals 23, because 2 times 10 plus 3 is 23. So that's just like a little life hack whenever you're solving proportions. Yeah, if the fraction, if either part of the fraction is the same, the numerator equals the numerator, the denominator equals the denominator, vice versa, then everything is equal to each other. Okay, last one. 23 over 17, 35 over 3x. Okay, so 23 times 3x is 69x equals 17 times 35. That's another one I do not know off the top of my head. 595. Divide by 69. So x equals whatever that is divided by 69. And I got 8.623 blah 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 blah. Since it doesn't repeat or anything like that, I'm just going to say 8.6. So x is approximately 8.6. All right. Thank you so much for watching again. A scan of this document will be in your Google Classroom in case you need to go back and look at anything. If you have any questions, be sure to let me know. And thank you so much. Have a good day.